Welcome guys to the very first tutorial video on dynamic programming. Before straightly jumping to dynamic programming, I want you all to believe the fact that dynamic programming is a solution to recursive code. We'll take an example and proceed with it. The very basic and the most popular example is of a Fibonacci number. Like if you don't know what is a Fibonacci series, it is in Fibonacci series the first two numbers are fixed as 0 and 1, and then every next element of the series is generated by summing up or adding up the last two elements. Like we have 0 and 1 fixed, the next will be the sum of these two, 0 1, which will result to 1. Again the next will be the sum of last two, that is 1 and 1 will return 2. Then the next will be the sum of again last one, that is 1 plus 2, which will give 3. Then 2 plus 3, that will give us 5. So the recursive code of Fibonacci number or Fibonacci series will be something like this. If we want to know the nth term, then we'll compute the n minus 1th term and n minus 2th term of the series, and then we'll sum the both and return. We will do computation, and if we reach the first or the second term, that is 0 or 1, then we'll return it as it is. So this is a simple recursive implementation of Fibonacci number. Now we'll see what is the problem associated with this. So as you can see, if I call with the value of n as 5, like the fifth term of Fibonacci, what it'll do, it will compute for 3 and 4. All we can say that it will do a recursive call with a value of 3 and with a value of 4. 3 will again do a recursive call for 1 and 2, and 1 will again do a recursive call for 0 and 1. 4 will do it for 2 and 3, 2 will do it again for 0 and 1, 3 will do it again for 1 and 2, and 2 will again do it for 0 and 1. So what we can see, that there have been multiple calls to a same function with the same argument. That means we are computing f1 or the Fibonacci 1 multiple times, though it will return the same value every time, but we are doing it for multiple times. This is acting as the overhead to the complete process. So what can be the solution? That we can store the value whatever we are getting for the first time itself. That means we store the value for f1 and we store the value for f0, and then we use it anytime we require it. We do not to compute it. And even we can see that 2 is being repeated multiple times. So what we can do, that we can store this value somewhere and use it instead of calling the function again and again. Let me show you something. Okay, so here's the code for Fibonacci. That is, if I want to call it with a value for 5, okay, let me just zoom a bit. So as you can see, if I want to call the function with the value as 5, I'm printing every time I'm invoking the function. So let's see how many times does it get printed for n equals to 5. So as you can see, just to calculate for 5, first it calls for 4, then 3, then again the recursive call it for multiple times. As you can see, the 3, we have called f3 twice, we have called f2 also multiple times, and similar is for f1. So what can be a probable solution for this? That we start storing the result. So here comes the very first rule of dynamic programming, that is tabulation. Instead of calling a function again and again, we'll store the value the first time we calculate it. Simple enough. And the second rule comes as, we'll break the problem into smaller problem. Like for example, if our question was to find the fifth term of a Fibonacci, we'll first find the first term, then the second, then the third, then the fourth, then the fifth. Simple enough. Now I'll take the same example of Fibonacci, means generating the fifth term of an Fibonacci where the first two terms are fixed. So in a dynamic approach, I won't go straight away to calculate the fifth term. That was a recursive approach. What I'll do, I'll first calculate the third term, that will be the addition of first two. Simple. Then I'll calculate the fourth term, 2. Then I'll calculate the last term, it's 3. So what we have done, instead of going to a recursive call, we have made a table that is simply an array. In a layman wise, it's simply an array that is acting as our table. The first index is storing the value of the first term. Second index will be storing the value for the second term. Similarly, third will store for third, fourth and fifth. So first two elements or the value for the first two index are already known. Starting from third till our nth term, we'll just sum up the last two and store here. Similar na? Now if I need f equals to 5, I know the value of f equals to 4 and f equals to 3. I need not to compute it again and again. So simply I'm storing the value in a table and using it when it's required. So let me again show you the solution. So this will be our dynamic approach. Same, we are calling for f equals to 5, but this time we are using an array. Simply if like for example, if we want the Fibonacci for n equals to 1 or n equals to 2, then we can simply return the value. That means the first one is 0 and the second one is 1. We not to do any programming or dynamic programming approach for it. When it is needed, that is when we need to calculate for any value that is greater than 2, that is third term, fourth term, fifth term or any nth term. So in that case, what we do, we first build a table with an index, then we start computing the values, means we start filling up the values starting from 0 till n. Initially, if it's the first two index, we'll store 0 and 1 as it should be. If not, then we'll use the last two term to get the final or the outcome term. So let's see if this works perfectly. So yes, we got the output as 3 for f equals to 5. So let us revise. The first term is tabulation. We'll store the result in an array. Can be 1D, can be 2D as per the requirement. Second, we'll break the problem into smaller problem. We won't go straight away for nth solution. We'll start from 0 or 1 and then we will reach till n. Taking the Fibonacci example, we'll take an array of, if we want to print the nth term, we'll take an array of n index, of which first two index will be fixed. We'll start computing from the third index till nth. For third, we'll add up the last two, which is our stored value of the table. Again, for fourth, we will use the value stored in second and third index of our table. For fifth, we will use the value stored at third and fourth index of our table. So this is the pseudocode for the same. Now, is this the best solution for Fibonacci problem? No. We can even do this using two variables without using any of the table. So the motive of this video was not to give solution for a Fibonacci question, but was primarily to make you all understand what is dynamic programming, what is the approach, and why is it needed. Though we have a better approach for this question, but there are many questions where the DP are the most optimized one. But this one will be the best to understand the approach. So in future videos, we will see all the dynamic programming problems where the DP is the most optimized solution. So thank you. That's it for this video.